Hello, ma'am. வந்துட்டேன்.
Ma'am, shall we start, ma'am?
Okay, ma'am. We'll start, ma'am.
Yeah, just a minute, ma'am. We'll start recording.
Okay.
Yeah. Suganya, ma'am?
Yeah, ma'am. Can you hear me?
Yes, ma'am. It's audible.
Yeah, ma'am. So let us start.
Yes, ma'am.
Okay. So good evening, everyone, and welcome you all for today's session on power system resiliency enhancement using renewable energy resources. I would like to introduce our speaker, Mr. Balaji Venkateswaran, currently working as Assistant Professor in Electrical and Electronics Engineering Department at University of Petroleum and Energy Studies, Dehradun, India. He is a certified trainer for distribution engineer issued by Ministry of Skill Development Corporation, India. His area of interest includes power system analysis, grid integrated energy storage system, and renewable energy. So welcome you, sir. Welcome all the participants for today's session.
Yeah, good evening.
Welcome you, sir.
Yes. So shall I start my presentation?
Okay, sir. You can start, sir.
Yes, sir. Yes. I will stop my presentation, sir. You can start, sir.
Okay.
I have stopped presenting, sir. Yes.
I just uploaded my presentation. Maybe it
Yes,
will
sir.
take some time.
It's visible, sir. It's visible.
Okay, is it visible?
Yes, sir. Yes, it's visible.
Okay. So good evening, all of you. I am Balaji Venkateswaran, Assistant Professor, Department of Electrical and Electronics Engineering, UPES, University of Petroleum and Energy Studies, situated in Dehradun. So here we mostly do a lot of stuff related to energy and petroleum. And other than that, I just want to mention that we have School of Health Science, School of Design, School of Law, School of Management, and School of Life. Recently, we have opened School of Life. So basically, the main aim of our university is to go towards interdisciplinary studies. Even though it is from electrical background, we do a lot of stuff related to energy. We do a lot of stuff related to design, and it is completely a multidisciplinary one. Why I am giving an introduction like this? Because the topic which we are going to see today, power system resiliency enhancement, that is also basically an interdisciplinary topic. That is also basically an interdisciplinary topic, which combines starting from civil structures and many algorithms involved in planning the system, and then moving towards developing the system towards increasing the enhancement of the withstanding capability towards any natural disaster. So this is the core aim of power system resiliency. And when I say resilient, it obviously means that how rigid or how you can withstand the change which you can face in. So the resiliency term is not new to new to us in general, but in power system, the resiliency term, I think it is coined in in the early 1900s. But in recent days, in power system, the resiliency term is very popular. And since the introduction of renewable energy resources, I call it as RERs. So renewable energy resources integration is greatly done, especially in India. We have a vision towards 2020 having a 175 megawatt of renewable energy resources into a grid or in any means. So integration of these renewable energy resources may have some positive dimension, like increasing the flexibility of the grid, but however it may also give you some trouble. But mostly those troubles are can be overcome by using the latest technology of inverters which we have. Coming to the point again, the resiliency. Before moving on to the resiliency, I want to emphasize on two categories. As I mentioned, resiliency is basically how do I withstand to the change which happens abruptly. How do I withstand the change which will happen abruptly? So I have to take two categories here generally, and the two categories of the things are, one is crisis and the other is disaster. See, the crisis generally it means that human-made activity. Because of human error, any equipment got failed. Because of human error, the transformer has burned. On the right side, I've mentioned, if you can see the pointer. So the right side I've mentioned, because of maybe the accident happened, the transformer pole has fallen down. And in the bottom picture, I've mentioned there is a flood, and you can see there are some sparks here and there because the live wire has got down and it has created short-circuited. So there are two things. One is crisis, the other is disaster. The crisis may happen because of the human error, and the disaster may happen because of the natural calamities which we often face. For example, if I take Chennai, in 2015, we have seen the Chennai floods. So during that flood, I'll just I just want to mention the problems which we have faced in the flood, during the flood, so that it will be very helpful for us to get through the insight of the problem which we are going to discuss. So during the Chennai floods, if you can just rewind, those who are really situated in Chennai, they could able to grasp what I'm trying to convey. Many houses are underwater, and mostly the first floors, from first floors only people can live, and mostly the substations are gone down. It is underwater, and then the bridges, we have subways, right? In Chennai there are many subways, so the subways is completely closed with the water. So everywhere you see there is a chaos, there is a havoc chaos, you know. The main problem which we had is the proper planning was missing. Am I audible? The main problem
Yes, sir,
is
it's audible.
yeah.
Yes.
Chintamani ma'am, if you can switch off the mic, I think I'm hearing a lot of disturbance.
I will mute her, sir.
Thank you.
Thank
So
you,
yeah. So we have to understand the point that we have faced a lot of problems because of improper planning, or there is no planning at all, I should say. So that's why the resiliency studies, it can be categorized into many ways, which we are going to discuss, and then how to ignore or how to come over those difficulties using areas we'll discuss. But the main point is there should be proper planning. So I mentioned that resiliency will definitely come under two categories. One is operational and the other is hardening. I'll tell you the brief about those things in detail shortly. But planning activity is indulged, or I should say power system planning and resiliency, they both come hand to hand. Yes. So the problem which people faced were the government officials could not switch on the pump which is already installed in the subways, because it is completely drowned inside the water. And after getting the water out using some diesel pumps, then also people could not able to switch on the pump, because it is basically some pumps cannot be switched on because basically there is no power supply, and there are categories like this. And if you see, some substations are completely down into the water. The general standard is you can have three feet. Above 3 feet, all the equipments, major equipments of the substations will be installed, but it is completely inside the water. So something like this, if happens, then what should we do? You may ask the question, sir, it is a low probability, high impact, low probability. This is what people call high impact, HI, low probability, LP. High impact, low probability. The impact is very high, but the probability of occurrence of that particular event or the disaster is very rare. So why should we bother? That's what the Indian scenario was all about. And if you see the topics, especially the papers, the literature related to resiliency, mostly the articles will be related to the US-based studies, case studies, especially the popular models you can see are based on hurricanes, because their hurricanes are very popular. It will be coming every year. So they have developed the model, and they have a proper infrastructure to study the power system resiliency and how to improve that as well. But to be frank, in India, if you just see the repository from National Authority of Disaster Management, for the past few years, you can just compare the data which I'm just telling you now. Between 1970s to 2000, there were only nine natural disasters occurred between 1970 to 2000. And from 2000 to 2010, it was slightly increased. And from 2010 to 2019 especially, it has increased to 19. So it is very essential for us to rethink or redesign the process which we do for power system planning. Or we should go, this topic should be completely interdisciplinary bringing the civil people inside, bringing the municipal corporation people inside, and bringing the power system planners inside, and the electricity board people. And we have to completely redesign the power system to withstand the natural calamities which might be faced. Okay, so moving on. So what are all the causes of disaster? As I mentioned, floods, we have a very good example, Chennai floods, and you can go through, there are reports available where you can see inside the house there are 11 feet, up to 13 feet, the water is completely filled because of the flood. So we had experienced flood, we had experienced tsunamis, cyclones, maybe hurricanes is not possible, or at least in India, and we have experienced earthquakes, Gujarat earthquakes, and the earthquakes, the place where we live in Dehradun, this comes under zone 4, earthquake zone 4, seismic zone 4. So if we just slightly go upward, the district called Pithoragarh in Uttarakhand, it will come under zone 5. Every once in a year or twice in a year, you can see a major disaster occurring there because of earthquakes, landslide occurs, and then a major disaster occurs in the locality, and few lives will be lost and many property damage will be there. So we should definitely take care of all these things, especially in the power sector, in order to serve the power, energy served during the particular condition. Because the main problem is, even during the Chennai floods, we can compare, there is no power, and communication was shut down. Only BSNL was working, if we remember. Only the landline connections were working. Other than that, there is no telecommunication. Wireless telecommunication is completely gone, because if you see, each tower, inside the tower you will have a diesel generator and a battery system, and if diesel generator fails, your battery activates and it will give power until 12 hours. Battery backup will be there. But due to the flood, it is completely drowned inside the water and there is no idea what to do. So that's why all the communications are gone and only landline connections were there. And due to this, we have faced many problems. So as we are trying to move inside the problem, we can able to understand that this is not only related to having the substation under right condition or having the distribution lines under right condition. This talks about the holistic aspect should be developed, like communication, and even the power sector industry, you have substations, and even the renewable plants. Yes. Now, there are departments, disaster management departments are there, and they'll plan. But the point is, these disaster management people in the municipal corporation or maybe in the town planning, they will particularly focus on the people's development, or they will particularly focus on the properties which are belonging to the municipal corporation or the town panchayat or the city, like Greater Chennai. Yes. So the power system aspect, from the power system aspect, the electricity board people has to plan this accordingly. And that's why I mentioned, if you can classify the natural calamities, it can be grouped into major types and minor types, depending on the potential of damage it will be costing to us and the human life. For example, if you take the disaster Hudud, which occurred in Vizag in the year, I think 2014 or 15, during that period, almost the Vizag airport is completely gone. And many houses, they were facing power crisis. There is no power for at least 1 week, similar to the Chennai people who faced the power crisis during that time. Similarly, across the India, if you see, always we heard in the news that Odisha is facing the cyclone this year, and it came to hit Tamil Nadu and went towards Andhra Pradesh and hit the Odisha. This is the generic news which I think 90s kid will always see in the newspaper. So it is very clear that the natural disasters is increasing every decade, and we should definitely redesign and rethink our power system planning and to make the grid more resilient. Yes. So how the system can respond? What should be my disaster management plan in order to, in order to implement this, in order to make the life simple, or in order to make the system at least to serve the loads. So first is I've classified into 3 types. First is operational response, management response, and communication response. I think as the name itself says, we have 3 categories, where in operational response, if you see how do we operate in that particular region and given for the given condition. So it depends on the disaster. For example, Chennai floods, you have to approach the operational management and communication response is different. For the cyclone which has happened in Vizag, Hudud, the management plan will be different. For example, you take the landslides which is happening in the Petroleum districts, as I said. So the plan is different. So depending on the disaster, the management plan will be entirely different. So majorly, the power system planners, what they do is, they should try to get the most common disaster in that particular location, so that, so that the power system becomes more resilient to the most common disaster. And as I mentioned, management is, you should have the crew. The best example I should say is, I think in 2015, the Chennai has faced the worst flood, and since we had no idea about the floods and stuffs like that, for especially for the the corporation of Chennai, but the next flood which we were expecting, I think in 2017, but the government was very cautious. They have responded very correctly. They had the management response, in the sense they had the crew. Wherever essential, they had placed the particular crew in that position, and they ensured that the communication line between the crew and the managerial people who are trying to manage, those are perfectly on place. If this is done, then you cannot ignore the damage which is caused by the property damage which is caused by the disaster, but definitely yes, you can try to ignore the damage which is caused to the human life. At least for the human life, it can be ignored. This is the generic plan which is generally done, not basis on the power sector, but generally I was trying to give you an idea how people will try to respond, especially from the corporation point of view. Yes. So before moving on, let us try to understand the definitions, so that let us be clear what the resiliency is all about, or what resilience is all about. So as I mentioned, resilience resilience term is itself an interdisciplinary term. Even a chemistry people will be using, even a civil people will be using. So that's why I've categorized into some disciplines like infrastructure system, economic systems, social systems, organizational systems. So the best example is, now in the COVID situation, the organization is facing, not only a single organization, many organizations have faced this crisis, or the disaster I should say, and how do they manage to come out? How do they handle these perturbations? That also becomes a study, especially for the people who are doing HRs. HR and MBA personnel, they'll be trying to understand the resiliency in this fashion. And similarly, the social aspects, similarly, the economic perspective. Even in this situation, we have the huge economic loss, and how we are going to face, and how we are going to absorb this, and how we are going to rebuild the economy. Similarly, the infrastructure. So basically, the term resilience means how the system is going to withstand the stress which is caused by the perturbations, or maybe from the outside environment, and how it will recover on its own. Or if you have any plans, what are all the plans we have to make the system work again and try to bring it to the normal situation. So that is what the core idea behind the definition of resilience. Now, we can ask a question like, sir, what is the difference between the resilience and the risk management, because I just told this disaster management plan is simply nothing but a risk management plan, right? So I just want to give some significant difference between these two, because there is always a confusion between the community that risk management and resiliency studies are approximately same. Yes, it is approximately same, but not the same. By taking PAR model for risk assessment, if you see, if you have a risk or any disaster or any attack, it will be classified. What type of hazard it is going to occur, what is going to cause, and vulnerability and capacity will not be that much taken into account. But if you see the resiliency framework, the hazard, basically the main difference between these two is, let's say I'm going to take again the Chennai flood example, because basically I'm from Chennai, so and affected by the Chennai floods. So that inspired me to work towards this area. So in the resiliency framework, the main parameter which is to be concerned is time. So for example, I'll give you one slide, maybe a practical example, so that we can just rethink that. Those who are especially in the areas like in Chennai, if you can recognize, there are cities like Mambalam, West Mambalam, and Nungambakam, Mailapur. So all these areas got the power maybe within 2-3 days during the Chennai floods 2015. But the outskirt areas like Chengalpattu, Puduvancheri, Tambaram, and these areas, maybe the power came after 7 days or 10 days even. And even if you go down the line, the rural areas will be getting power after 1 month maybe. So the basic difference is between what is the timeline or what is the time for which you are serving the load as a power system engineer or as a power system planner. I should be able to significantly define what is the timeline for which I can able to serve the load for the particular disaster. If flood occurs tomorrow, then for what period of time, for what amount of time I can able to serve the load with the available capacity. So basically the difference between PAR model and resiliency framework is this is time dependent and that is not time dependent. And here we try to take each and every possibility, like durability of the equipments, especially for that particular timeline, and how severe the attack will be and how it can withstand, and vulnerability, how it can withstand. That's what the vulnerability or survivability says. Let's say if flood occurs, and even recently the floods, cyclone which happened in Kolkata, you see many solar PV plants, installed in the rooftop. It is completely damaged, and till what time it can survive, that time is very essential. And the last but not the main important point is self-healing capacity. What will be the time taken by the network to self-heal and come to the position, back to the position? So that's what I want to mention between the comparison between PAR model, because those who are in the industry, they can understand the PAR model, because generally the risk assessment will be done based on the PAR model. Yes, coming back to the power system resiliency, the IEEE has already, in 2015, I guess, the IEEE task force has defined the term power system resiliency. Especially, it defines like the ability to withstand and reduce the magnitude and or the duration of disruptive events, which includes the capability to anticipate, absorb, adapt. So these are the points which is very, very important for the power system planner. So the system should anticipate for the disaster, and if it occurs, it should absorb. It should absorb in the sense it should withstand. Here we are talking about the survivability. It should withstand, and then withstand, and then adapt to the situation. Whenever I say adapt to the situation, it means that, for example, if a disaster occurs, the network should reconfigure itself on its own. So the network should reconfigure itself on its own, so that it will be adapted to the particular situation. Yes, maybe for example, we can take again the Chennai floods. Let's say people are saying that Chandrabakam Lake that caused a major disaster in the nearby locations. So how the network is going to reconfigure itself by using the ring main. I think we all are familiar with ring main units. It will have the switches wherein you can RMUs. So you can try to remotely switch the power supply. But basically in India, we have ring main units from the main feeders only, but not in the core level of distribution. Because it is very difficult for us to improve the resiliency of a distribution system rather than a transmission system. We'll discuss that sometime later. Yes, how do I adapt my system? Coming back to this, how I'm going to adapt my network, and this adaptation will be there until the event is present. For example, if the flood occurs now, there should not be any power cut. But recently, not recently, maybe we all would have recognized that once a slight tufan will come, tufan in the sense the cyclone will come, and suddenly the people will shut off, because the safety is the prior importance. That I can agree. But how do we serve the load? How do we serve the load? Because all these point of view, whatever we are talking about, everything is money. When we are going to discuss how we should satisfy the load, we can ask the question, sir, why we should try to serve the load, especially during the disaster? Why? There may be a question, why? The basic point is there are critical loads like hospitals, like your community centers where I think if Chatram, I think in Tamil they say Chatram we will try to serve people, those who are affected. We'll try to shift to the community centers. So there you need electricity. So electricity is needed, especially where the places we try to accommodate people during the disaster. One more thing, in the communities, in the large communities, if there is no water, because in these days, cities like Chennai, Delhi, Mumbai, we have many apartments. If we don't have electricity, then we cannot imagine how people can live there without pumping the water from the sump. They buy from rural areas, and then they store the water, and then they pump it up into the overhead tanks. So 1 day, 2 days, it's fine. Otherwise, it is going to be a very difficult living for them. So basically, since the electricity is combined with respect to the livelihood of the people, so it is very essential for Indian electricity boards to consider improving the standards towards instead of reliability. Reliability was always there. Reliability in the terms of SIDI and SIFI indexes we try to do, and almost all the electricity boards in India we try to follow the reliable supply. But we should also create the grid more resilient. That is what the futuristic grid should be, and then it should recover fast. So if you see in the right hand side, I've given first you have to identify the system identification, and then it goes left and then anti-clockwise. So system identification, and then you have to perform vulnerability analysis, and then you have to go for resilience operation, and then this cycle goes on. See, when I'm trying to model or when I'm trying to enhance the resiliency of any system, it is obviously grid dependent, or I should say location dependent. Because in Dehradun, we don't have floods, even though here the rainfall is tremendous compared to the other parts of the India. But to be frank, it starts raining from July, and it goes up to August or September. Till September, and you cannot imagine, it's continuous rain. And if rainfall occurs, then the people who are traveling in two-wheelers, they cannot go. You can just imagine. So it is that much of rainfall occurs. But there is no problem, especially in this region, because the roads are having a particular slope. Because since this is situated in a hilly region, it is not going to be a big problem. But the problem comes because of landslide, rainfall leading to landslide, and because of earthquakes. So that's why it is very essential for us to identify the system, what system we are going to work on, and then we have to perform the vulnerability analysis. So when I say vulnerability analysis, it is like this. Maybe I'll try to give more details when we go to the future slides. But we have to just understand what are all the equipments, main equipment. For example, if I'm going to take substation, or maybe the transformer inside the substation, that is very, very important. I think the industry fellows can understand, if you have the shaking of a transformer, if it goes beyond 5% of its limit, then the bushings will be short-circuited and the transformer may not be working for you. So in the case of earthquakes, I'm talking about. So in the case of floods, if the water intrudes into the substation and goes beyond the limit, then again the relay trips down and your transformer will not be available for service. So it is very essential, after identification of the system, we have to identify we have to perform the vulnerability analysis concerning to each and every equipment in the system. For example, in a distribution system, if you take the substation which is coming from, let's say, Avadi substation, and there you have 33/11 kV substation, and from there, how the power is distributed from the transformer and then with the help of poles. So all these poles and the transformer are very essential for us to get the continuity of the supply to the load. So all the equipments which is being present there, it should be involved in the vulnerability analysis. The main problem in this is, especially in our region, especially in India, is we have the locations of the substations, because here we have to map the location. The GIS comes into picture here. We have to map the locations. GIS mapping should be done for all the components in the system. Then only the vulnerability analysis can be easily done for all the nodes in the system, and we can easily identify if any high impact, low probability event occurs, then what part of the system will be isolated, or what part of the system will not be served. So that can be understood. But the main problem here is we don't have GIS technology, GIS substations all through the nation. It is not possible, and GIS mapping is not done. Very few substations or very few distribution companies are taking up this. So that is the major disadvantage in the current scenario. But I hope if once it is a significant amount of time and money is invested in getting the locations and the data relevant to the disaster, it shouldn't be a problem. And then resilience operation. See, once you know this is what the vulnerable location is, then whatever the strategy you try to apply, it is completely based on the power system planner. There is no particular set of rules for which we should follow, and for the operation of resilience. Just a minute. Yeah. So there is no particular rule to follow. Basically, it depends on the strategies which the power system planner is going to build, and then with respect to that, what is the strategy which he is going to follow for the particular given situation and the budget allocated for him. Yes. And then, as I mentioned, vulnerability, we are going to perform for before event, during event, and after event. For all these things, we are going to perform. Yes. So, as I mentioned, vulnerability, again, it is different for earthquakes, it is different for tsunami, it is different for floods, it is different for hurricanes. So, basically, the vulnerability of the equipment, for example, the distribution poles, especially the distribution poles installed to transfer maybe 11 kV distribution pole, or even you can assume a 440 distribution pole, because almost the concrete poles will be same for both 11 kV, except the fact that the height will be different, slightly different for 11 kV and 33 kV. Right. So now we have to concentrate. Let's say if there is a huge rainfall occurs. So I don't think so there is a problem because only rainfall will not disturb my poles. But the fact that rainfall with a high wind speed will definitely topple the structure, causing the damage to the problem. So this is the basic example I can just point to understand that the power system is vulnerable to different type of natural disasters, and for different type of natural disasters, the planning must be different. Yes. So as I mentioned, the natural disasters, severe weather conditions, and attacks may be reliable. Attacks make reliable operations of power system a very difficult task. Yes. Not only the physical disaster which I am talking about, there are chances of cyber attacks, because as we all know that the power system is transforming from the olden control units to a SCADA based control unit, and now you can see many IEDs installed, intelligent electronic devices installed in order to remotely control every unit and monitor every unit. I'm sorry. So remotely control and monitor every unit. So if there is a data which is coming from IED specifying that the particular thing is damaged, but it is not really damaged, then it also causes a problem for us. So that's why in power system, there are two categories, or we can say that there are three categories combined. One is only physical grid component, which is damaged due to the event. And second thing is the cyber infrastructure damage due to the events, and both correlated. We have both happening, because if IEDs are damaged, then you don't get the data. Maybe because of the disaster, IEDs are damaged. Maybe because of disaster, both the things are damaged. Maybe because of disaster, only the physical grid is damaged, or the grid structure is damaged. So everything comes under the power system resiliency. So there are techniques and procedures which should be followed. The generic procedure is there, which should be followed, as I mentioned here. Identify the system, perform vulnerability analysis, and develop your own strategies to come out from the vulnerability, and then it goes like that. Yes. Now, as I mentioned, the physical vulnerability, the primary means of vulnerability is the severe weather conditions, and we can see the transmission lines and distribution lines getting affected because of rainfall or because of heavy wind. Like due to the wind, maybe the pole is not toppled, but the lines, because of the high sagging, it will touch each other, and then it may create the fault. And second most component, vulnerable component, is as I mentioned, the transformers. So how do I face all these problems? The only thing which we can try to use to mitigate all these things is hardening the distribution lines or the transmission. Mostly the transmission lines are good enough to face all these problems, because it will be designed in such a way that the transmission lines we have a more resilient grid. But coming to the distribution system, it is very, very difficult for us. One example I should try to give you in this point, like I said, the faults by contact between the conductors. See, especially in Dehradun, if you see in the UPCL, Uttarakhand Power Corporation Limited, these people have invested a lot of money in bringing ABC conductors, aerial bundle conductors, ABC conductors, aerial bundle cable. I'm sorry. So all these are cables which will be coming, and from the cables they'll be getting the supply. So with this, replacing the normal OH line, open or bare OH lines, replacing that with ABC conductors, it will drastically reduce the number of failures which occurs due to fault. And similarly, the theft and other advantages are also there. I hope we can understand. But the main thing is, when I say hardening, that is hardening. Trying to replace the current equipment which is creating the failure with the new equipment which is more advanced and which can withstand the particular event for more period of time. I hope I'm clear. So can we have questions now? I think it's approximately 1 hour. So can we have questions, and then I can proceed.
Participants, if you have any queries, you can please ask. Any queries from the participant side?
Yes. Yeah, okay, I think I should continue. Fine.
Yes, sir. Yes, thank you.
Yeah. Do you have a question?
No, sir. No.
Okay, fine.
Yes.
Yeah. This is what hardening is all about. As I mentioned, replacing the bare conductors with the ABC conductors. So, but there is a cost involved in replacing. So the overall operation, which I have discussed here, resilience operation. So when we are going to develop the strategies, even for example, if we take the strategies which we followed in the anticipated flood in 2017, we had invested a lot of money in developing the strategies and plans and putting the crews over there. All these are involved with money, right? All these have some investment in it, on it. So we should take care of the budget as well. So hardening comes with budget. Hardening comes with, obviously, it comes with budget. And structurally, if we can reinforce the towers and poles, if possible, if we can change the rusted poles, if you can see in the distribution lines, some poles will be RCC where we can see a slight bend. Obviously, I have seen many in the areas of outskirt area of Chennai. I don't know inside, because inside Chennai, almost all the areas are covered with the underground cables. So that should not be a problem. And that is why they have got the power within 2 to 3 days. And the other outskirt people suffered a lot because of the chaos happened. Large number of distribution poles damaged. But if we could able to retain the strength of the cable, retain the strength of the distribution pole back to its original form, then the impact of the disaster can be minimized. So there should be proper checks for the within the periodic time. Let's say if the lifetime of the pole is 10 years, the power system engineers, especially the TNEB people or any electricity board people, should try to invest on the inspections for each and every pole which is installed, so that this situation can be avoided, or we can try to reduce the hardening cost. So this is one type of strategy which I am trying to propose. And the last one is how we can try to achieve the vulnerability. You said, yeah, it's fine. But how do I mathematically derive what is the vulnerability? The best part which we can do is by using the fragility curve. I think most of the civil people will try to grab this, the term fragility, especially related to the structures. When I said transformer, distribution transformer or any power transformer, any transformer which is installed in the substation, if it is going to face the wind, or if it is going to face the earthquake, or if it is whatever the flood or whatever the disaster which you are going to see, the fragility curves are developed basically based on few aspects. I'll come to that, and then I'll try to address this point. So how do I develop the fragility curves? This is the fragility curve of a particular component in the power system, and here in the x-axis you will see the weather intensity. I did not give any scale particularly. It can be wind, it can be earthquake, peak ground acceleration, we call it as for earthquakes, PGA, peak ground acceleration. So it means if any earthquake occurs in any point, so what is the field you had, what is the ground shakiness you have in terms of Richter scale you can have, or in terms of moment magnitude you can have. So basically that's what it means. Okay, the weather intensity means that. And weather intensity in that particular location where the component is installed. So if that is the case, in the y-axis I'll have the probability of failure. When I say fragility probability, it is nothing but the probability of failure. So if obviously I can see starting from 10 to 90 in the scale, weather intensity, for 30 it is not so critical. The failure probability is not so there, but it starts from 30 and it increases And there are equations we can develop. It is basically dependent on what type of disaster, as I said earlier. So I'll give you references and examples on how to achieve these curves. But if you see, if the weather intensity is 80, then obviously the system will collapse. Obviously the system will completely collapse and you don't have any idea. You have to forget the system. So this curve is very, very essential. As I mentioned here, this curve is very, very essential for us to understand the vulnerability of the system, any component. Yes. Now, how do I develop these fragility curves? If you see, there are 4 ways in which you can do this. When I say expert view, that is the best I can say, because the industry people who are experienced, maybe 30, 40 years, they know the system very correctly compared to the young engineers who are coming and working based on mathematical models. My preference will be always to the expert point of view, because sometimes it will be very difficult for you to go for statistical model, because you need to have a large database. And even now you can see, if I ask the industry people, especially from maybe any electricity board people, they will be having the data, especially for the failure data. At least I should say the unintended outages or unplanned outages. So if I ask the data, it is very difficult for them to produce. At least 5 years data they may have, because of the infrastructural development which we had within the system. But before 5 years, it was very difficult, because all were not noted, and if it is done, then that too it is handled. So it is very difficult. But rather, if you go with the expert view, it is always there. So you can easily try to grab, okay, if this is the wind speed, then what type of probability you can say. So from that you can try to develop. If you have large failure database, from that you can derive a statistical model, so that you can derive the failure probability of that particular equipment. Remember, all these fragility curves are equipment dependent. It is not for all. It is not for complete power system. When I say substation, the fragility curve is different. When I say substation, in the sense transformer, okay. So when I say, because the major equipment in the substation is transformer compared to others, so that's why I mean that. I meant to say it is a transformer, and especially the HV transformer. Yes. If I say distribution lines, then the fragility is completely different for that. And if I say the poles structures, then the fragility is completely different. Obviously, when I say distribution lines, it is the fragility of the poles itself. So this through the statistical model you can derive, and do experimental based. When I say experimental based, generally the civil structures, especially the people who are trying to develop a component, like if you try to develop a transformer, once it is done, or it is something like this, you might have seen in the TV also. Whenever people are going to launch a new car, they'll be having a lot of road test. And this is basically what they're trying to do. They're trying to just go for the experimental based characterization of the particular car or particular model. And even in today's day, in today's scenario, if you take e-vehicles are under, many e-vehicles are under road test, they say. So it means that they are going to go for experimental thing, and they're going to record all the responses through sensors. And for example, if I take a transformer, I'll provide the shocks artificially, so that I'll try to see what type of damage it is going to cause to my system, both physically in operation and without operation. So all those aspects will be studied. And when I say simulation based, I think the name itself says through simulation softwares, through structural analysis especially, you can try to develop the fragility curves. And maybe you can ask, sir, is there any standard curves available? I'll share the few of the references which are generally used, especially which is modeled by FEMA, Federal Agency for, it is an American-based agency, federal agency. They have developed the different models, like as I mentioned, hurricane models is very popular from their database. So I'll try to, so those who are working on traction lines, it is again an important point to to note down, and maybe we can bring in the power system resiliency concept inside the traction as well. Yes. Coming to the cyber vulnerability, as I mentioned, in recent days, the power grid is getting smarter. We have a lot of communication equipments, infrastructure, IoT, whatnot. All the devices we are going to integrate into the system in order to make the system more, I should say, interactive. See, the moment smart grid come into picture, we should you can see many articles and many investigations came along with that related to cyber attacks. So obviously, it is very essential for us to look into the cyber vulnerability as well. For example, small commands which is received by the measuring equipments, it can lead to a complete system damage. And if people are working on this line, especially there is a stream called bad data analysis in the power system state estimation. So if you can get the details of bad data analysis, it is very, very similar to the cyber attacks. Whatever the data which is coming from the IEDs or the remote devices, whether it is valid or not, whether the data which is coming from, let's say, far from the place, whether it is going to be true or not. That's what the simplest form I can say related to bad data analysis and the cyber vulnerability. But you can go into in-depth analysis basically if you are interested in that topic. Next, as I mentioned, the combination of both. You have the wide area, regional, local, home area networks. And then you have here control levels, like you have substations, central control, substation control, and primary and secondary. So all these things will be disturbed if the link between the physical component and the cyber component in the power system, if it is damaged. Yes. Now, how do I build a resilient power system? See, as I mentioned earlier, building resilient transmission system is approximately done. I should say like that, because mostly all the transmission lines we have PMUs installed. I hope we all are aware, especially in this time. I think phasor measurement unit is the popular topic which is going on, and in India also we had a pilot project a few years before. And then we had approximately 1,700 PMUs installed across India. And basically, the PMUs are related to transmission networks. In the distribution network, there are some equipments like micro synchrophasors, and the line sensors are there, but to bridge the gap, basically. But it is a very costly affair for a distribution company to invest on. But if you see, especially in the systems where SCADA is already implemented, they'll be having fault line detector, FLDs. If you can search in the Google, it will be fine. So fault line detectors, it will be similar to the structure which I have just shown here, the sensors. That is also a sensor, but it will basically, what it does it do? It will try to send the command. Basically, it is battery operated. You don't want to have the power supply on the line. But once the fault occurs, it will try to send the signal wirelessly into the control center. So similarly, we need to have that type of setup in each and every poles, or maybe each and every end of the line between the poles. In order to make the distribution grid more resilient, because as I mentioned, the data is very, very essential in order to have any type of strategies which you develop. So now, a resilient power system needs structural flexibility, and the distribution system should make its own decision. It should be intelligent. Like as I mentioned, it should adapt on its own. So what type of configuration is very essential. So the best part of AI will be coming here. You can find many articles recently coming up related to AI in terms of microgrids and AIs. So how I involve AI to form various microgrids to solve power system resiliency problem. And this is the new dimension. Very recently, the articles are coming up, especially in this dimension related to AI. If people can work in this area, it will be very easy, I can say. Those who are already familiar with AI, they just want to apply the concepts which we are going to discuss in further, and you will end up with some beautiful or wonderful solutions to solve the problem. And then, as I mentioned, the power system resilience requires the knowledge of the system behavior. When I say knowledge of system behavior, historical data and the real-time data, and what type of the data will be in the future. So historical, real-time and forecasting models are very, very essential for you to develop this resilient system. Just to give you an idea, just to give you an idea, in the industry, people will accept, at least in the case of the power market, if you are a solar power producer or if you are a wind power producer, you have to give the schedule, the next day schedule to the dispatch center. At least the 15-minute schedule will be given for the next day. I'll be forecasting today based on the historical data and the climatic data and all the data which is possible for me to develop this forecasting model or to have an enhanced forecasting model. And what is the tomorrow's 15-minute interval pay? I should give what is the forecasting model. I should give what is the forecast of the tomorrow. So the allowed error is approximately 8%. If 8% is violated, I'm sorry, less than 8% is always encouraged, but greater than 8% is not always encouraged, and the penalties has to be faced. So similarly, what I mean to say is the forecasting models should be appropriate. It should be more precise rather than just a forecasting model developed by any algorithm. It should not be the case. To give you a sense, the National Institute of Wind Energy, I think NIWE, which is situated in Chennai, Velachery, there people are using more than 100 algorithms to test what is the power generation for what is the power generation from the wind for tomorrow. NIWE is doing that. So coming back to the concept, the historical data of the system, the real-time data which can be obtained by the sensors, and the forecasted data. When I say forecasted data, basically it means the load, the power generation, maybe if you have the conventional or renewable based, any power generation, load, power generation, and the weather or the disaster. So these data is very essential, but in the present day monitoring system is not so much strong to face such an extensive knowledge. It doesn't have. So that is the main problem. And one more problem is you can achieve all these things in the transmission system, as I mentioned, but in order to make the distribution system observable, it is really, really going to be very tough because we don't have the particular infrastructure, the monitoring infrastructure to do so. Obviously, distribution system is lagging. Now, how there are many ways I'll be trying to discuss with respect to some case studies after this slide. There are many ways to enhance. As I mentioned, it's up to the power system planner who is having the knowledge of the system and who is having the funds related to the particular system or the equipment's availability for the particular system. Only then you can do resiliency enhancement. So coming back to the resiliency enhancement, one of the most popular, I can say, one of the most popular way to do this is to partition the grid into microgrids. I have mentioned in the right hand side, in this example, we have classified the system, or we have clustered the system, I should say, into 3 subsystems, and you can see small solar units are installed these are small solar units installed in order to serve the load, or maybe any distributed generators will be installed in order to serve the load. Okay, so the point is you have to break the system into small microgrids. This is one of the solutions. So once if the natural disaster is going to happen, then you have to localize the grid, or you have to form the microgrids, and then you have to serve the load within the grid. See, that is only possible. I'll just give you, that is only possible if the transmission lines are down. If the transmission lines are down, that is only possible if the transmission lines are down. But if you see inside inside the subsystem, the distribution line towers, this is going to be a big challenge. You can see many articles, research articles, saturated, I can say, in this region, in this area at least. The resiliency enhancement of a transmission system is approximately saturated, because the transmission system strength is already high, and if you can ask experts from industry, mostly the transmission lines will not go down, but if it goes down, then obviously it may take 5 days for a 220 kV line or 132 kV line. If it is going down, then it may take maybe 1 day or 2 days, but maximum 7 days also it can take. So in those situations, obviously, as I said, high impact, low probability. So considering that aspect, in those situations, you can obviously form the microgrids, and then you can serve the load. But when I say microgrids, again, there is a question mark. Like, there should be some source within. So how should I go for the distributed energy resources? We all know that in recent days, the people are going towards distributed energy resources, but basically based on renewables, to make the grid flexible in operation and to reduce the contingency. Yes. Now, let us try to understand how the power system components are influenced by the climate change and the weather. So I have mentioned few points which is already discussed, but I want to emphasize once more before going on to the case study. So that's why I've mentioned it again. The reliability and resiliency, they both seems to be same. If maybe in one of the slide, I'll give you some. I'll show you some index, resiliency index, because everything must be quantified, right? So reliability we have already quantified with respect to some indexes like SID and SIFI, and we have other indexes as well, but popular things are SID and SIFI. Similarly, resiliency also has some index, but if you see the core definition, the significance of both is approximately same. But the only difference is reliability relates to the condition equal to normal. When there is an abrupt change, when there is a climatic condition, when there is a disaster occurs, you cannot maintain the reliability. That's what people were saying in the earlier days. But now we are trying to shift from a reliable system to a more resilient system. I think I'm clear. We are trying to shift from a more reliable system to a more resilient system. So when I say reliable, obviously it is reliable to some extent. But when I say resilient, it will try to handle the change. It will try to handle the change. So that's what the point to be remembered is. So as I mentioned, the transmission line capacity is, the first, I wish to tell you related to the first point I want to highlight, because I have mentioned other disasters like windstorm and heavy snow. I'll try to discuss all those points. Basically, these are may not be related to a southern part of India, but in the northern part, in the extreme, like in Kashmir and even in some part of Uttarakhand, where we have heavy snowfalls, in the places like Oli, we have heavy snowfalls. There, these concepts are applicable. Like, yeah, the first point, as I mentioned, the transfer capacity of a transmission line can be limited by the maximum permissible operating temperature. See, what happens is the wildfires occurs, and I think even in our state, Tamil Nadu, between the forest, some transmission lines may move. We may not notice, but it may be moving. We don't know. Let's say if a forest fire, wildfire catches, obviously the temperature is going to be increased in the surrounding areas, which will try to get transferred into the conductor also. So the temperature will be, I mean to say, the temperature is increased. So the maximum permissible capability of that particular line, which was earlier there, it is reduced because of the wildfire. So this is one of the example which I can coin to the first point. The second point, this we can easily understand by hurricanes and windstorms. The lines has to withstand, and similarly the towers. See, what happens is, whenever there is a snowfall, the snow will be accumulated on the lines, and which will cause more pressure on the lines, and more sag will happen. So because of this also, these are interlinked. If the snow is accumulated, and then if let's say if windstorm hits, then there leads to a catastrophic effect. Like once snow is creating the sag and the wind is creating the oscillation, and then it hits, and then the fault occurs. So this is how the things will happen, especially in the regions where snowfall is heavy. As I mentioned, lightning strikes also can indulge faults. Obviously, it also comes under natural disaster. So these are the points which is very essential for us to focus on, because it is going to affect the power system components. So the last point, unlike the weather mentioned, do not damage the overhead lines, but the substation equipments will be definitely damaged. As I said, the transmission lines are really safe compared to the distribution lines and the substations. Because in our case, if we take the Chennai flood, which we can relate to, the substations are completely drowned inside the water. Substation. So, if that is the condition, even though the power comes from the 132 kV line, we cannot switch on the power, we cannot energize the transformer. So, the substation equipments are also having an extreme effect. Why I am specifying this? Because all the papers, all the research articles, if you see, approximately all, they are mainly focused on how to improve just by concentrating the vulnerability of distribution lines. Because already prior developed model is there related to the wind and the distribution line. So we can easily correlate and we can do the results. But there should be models which is developed towards the substation equipment related to all the calamities which we are going to face. Yes, there are different types of curves. So when I say resilient curves, I'll try to explain. There are basically two types of curves which is presented in the literature, or I should say, generally people talk only with respect to these two curves. One is resilience triangle and the other is resilience trapezoid. So when I say resilience triangle or trapezoid, it means the same. It is going to give the significance, the same significance. Earlier we have a normal state, and suddenly due to some event, some disaster, our system performance is drastically down, and then we'll try to improve the system performance by doing some recovery actions. It takes some time, TEE, end of the event, and affected, start of the disruptive event. So this time is called recovery time. Can I use this? Oh, beautiful. Yeah, this time is called the recovery time. Yeah. So in the resiliency study, the main aspect is how should I decrease the recovery time? That is one aspect. Okay, and since there is not much details available, this is a very old concept of approaching the resiliency problem. But in recent days, This curve, resiliency triangle, is modified into a resilience trapezoid, where you have the system in normal condition, and then due to some event, in this time event is still there, and after the event, the system is completely degraded. For example, if I take the Chennai floods, before flood, the system was working completely fine. There is power served for all the loads. Once the flood starts, once there is a indication that the flood is going to happen, we'll switch off all the power, obviously, because we don't have that much resilient grid. So obviously the grid's performance will go down. And here the event is ended. And now in this case, you are going to take some time. This is the preparation time, I should say. So after the event, your system is degraded and you are having some time. So this time is basically the preparation time, and then you start the restorative action, and then post restoration, you cannot restore completely. It's obviously you cannot restore the complete grid in a single go. As I mentioned, the Mambalam sector, the city sector, where you have the underground cables, the restoration procedure was quickly done, and then a partial load is recovered, and then after a few hours, a few days, the recovery starts again and completely it is done. When I say this recovery, it is infrastructural recovery, I mean, because most of the distribution poles will be falling down, and maybe the trees have fallen on the overhead lines, so you have to clear the trees. So there are many procedures which is there, physical constraints which is there to approach this. So the ultimate concept of resiliency, which we are going to discuss with the help of case studies, are we have to decrease this time. You cannot do anything with this. And if you can do, I'll tell you how to do sometime later. But you can plan this already, what should be done, so that this time, because everything, as I said, it is time dependent. The resiliency approach is time dependent, so you should try to reduce this timeline. And this slope of this curve should be increased, in the sense the time between these two should be decreased. It should go like this. Okay, but to be precise, we are aiming to have a grid. We are aiming to have a grid like, if a disaster occurs, there is no change. Disaster occurred, disaster went, even the performance of the system is same. So this is the ideal characteristics which is expected. But in the today's current scenario, even in the developed countries, we don't have the ideal curve. We are not near to the ideal curve, I should say. So this is the curve we are trying to follow. Okay. Yes. Now, how should I plan my distribution network? In my forthcoming slides, basically I'll be talking about the distribution sector, because I am closely associated with, even though I am a university professor, assistant professor, I'm closely associated with the projects of UPCL, Uttarakhand Power Corporation Limited. So I'll be basically discussing about the distribution system rather than the transmission or the other systems. Yes. So that's why let us try to understand how should I optimally plan? How should I optimally plan to have the grid, distribution grid especially, more resilient? See, I can classify the measures which we are going to put. We all have understood that what are all the types of climatic changes which we are going to face, and in this regard, what are the measures which we should take? See, some measures like hardening cannot be done overnight. Replacing all the overhead distribution lines to ABC conductors, it is not possible. So it needs a definite amount of time, a budget, and labor. Many aspects are involved. So that's why the classification is done basically with respect to two aspects. One is short term, the other is long term. So short term, within the speculated time, within this time, what should I do? What is the plan of action? And how should I restore the system? So that comes under short term, and especially hardening comes under long term, because you are going to completely change or improve the infrastructure of the distribution grid. Excuse me. Yeah. So, what are all the different? Do we have time? Yeah. Ma'am, do we have time?
Yes, sir. Yes, sir. You can proceed, sir.
Okay, because I have 40 slides. I just came half.
Okay, okay, sir. You can proceed, sir.
Okay. Yeah, thank you. So, short-term resiliency, it means that there are, as I mentioned, we are trying to, we are trying to focus on this region, and the measures which we can take to make the grid more resilient is, as we did in the 2017 flood, we have already deployed crews there. This can be done. Within short notice, it can be done. So deploy the crews, check for critical communication failures. If it is there, then try to deploy crews so that they try to repair the communication lines. It should be perfect. And you should create awareness among the people in the system. Like if a flood occurs or if any natural disaster occurs, how we should try to improve. And for example, demand side management should be done. The demand side management can be done within a short notice, like which we have done in the 9 o'clock night, where the POSOCO has developed the concept wherein we all in India we have switched off the lights at least, and which has caused approximately a 30% dip in the load. So how to overcome that? So these are all comes under demand side management. So we should try to plan for reserves. If this fails, then what should be the next? So these activities, the number of crews and these things must be done. Apart from this, the main important thing is your forecast must be very perfect, because you'll be completely dependent on forecast. I'll give you an example which recently happened in the Tamil Nadu only. Like in 2017, we were expecting that the cyclone will go away through some location, but unfortunately, it went on through the Trichy area, Trichy Perambalur area, and it has damaged a lot of plantations, especially the coconut trees. So I can say there is a flaw in the forecast. So whatever the pattern in which the flood is going to move, whatever we have attempted to forecast, it went wrong. So the forecasting, it went wrong, and that's why we faced a lot of damage related to the coconut trees, and a lot of farmers were affected. So that's why it is very, very essential for us to go for the forecast. The proper forecast will help you to come over and to minimize the effect which is, the failure which is caused because of the natural disaster. And long term, as I've already mentioned, you have to go for hardening the distribution grid. So when I say hardening, it means you can try to identify and try to replace some distribution overhead lines with ABC, as I just mentioned, or you can go for underground if it is possible, or if you can relocate the poles, because in some area what happens, especially in the hilly region, the pole which is already placed, due to erosion, soil erosion, the landslide will easily occur and the pole will fall, and this can be inspected and we can relocate the pole during the normal condition, so that you can avoid the disaster which is to be faced. So that is one of the major aspects. Relocation of it is suitable for both transmission as well as the distribution lines, especially in the case of hilly region. In our location, if you see, in the location of Dehradun I'm talking about, in the up the hills in the Mussoorie and Dhanolti region, it is completely hilly regions. Okay, it is something like our Ooty and Kodaikanal. So there, if the power lines will not be going along the road, the power lines will be going up the hill. So definitely there will be some poles which is installed, if I want to mention, see if this is the slope, let's say if in this region you have the road, the poles will be installed here and the lines will be traveling like this. I hope you can just try to recollect things. So under this situation, because of soil erosion and because of rainfall, soil erosion occurs, and then if there is no proper structure faced in order to avoid soil erosion at this point, then obviously your structure the poles will be damaged. So inspection of these and then try to harden it. That is also one kind of effort which you are trying to do with respect to hardening. Apart from this, how you are trying to increase, how you are trying to increase the, as I mentioned here, in this, you can try to develop the microgrids, but we should ensure that there is enough supply inside. So for that, you need to install distributed energy resources. If it is like solar PV or wind, basically solar PV we can take, because if sun rises, then obviously you get the power. Okay, so those type of aspects should be encouraged and should be installed in the distribution grid. And we should also try to include energy storage. Recently, the topic of energy storage is very popular in the area of power system resilience. And I'll try to discuss some point with respect to few of my publications under this area. And the distribution generators and then the demand side management. Basically, we are aiming to have a self-governing microgrid formed when there is a threat of natural disaster. That is the bottom line of this. Yes, I'm going to take an example here with respect to the idea which we got till now. I'll be fastly moving through the slides in order to understand how the planning activity is done in order to enhance the resiliency. And for that, I've taken the distribution network. And since the model is already available, the hurricane model, since the hurricane model is already available in the FEMA website, so that's what I thought of, taking this model to explain the enhancement plan, so that you can try to develop equations and try to solve on your own. See, as I mentioned, this is a planning activity, and basically it is very, very similar to the problem which we solve, like optimal placement or optimization. It is very, very same. The only thing is the constraints and the objective function, or the way in which you try to formulate the problem defines how strong your resiliency planning is all about. So basically, I want to say, whatever we are going to discuss from this slide, it is nothing but the optimization, power system optimization. Can take any area, optimal placement of PMUs, optimal placement of energy storage devices, optimal placement of renewable energy system. Everything can be included in this aspect, because this is also an optimization. But how do you formulate the problem, and how do you ensure that you try to indulge all the practical aspects which we have just now discussed, like your inclusion of disaster management plan, inclusion of civil structures, inclusion of the failure vulnerability analysis. How you are going to include all these things into the problem to have the enhanced planning for resiliency? Yes. So in that case, I'm just going to take an example: resilient distribution network planning to reduce hurricane damage. So this is what I'm going to take as a case study. So here, the main objective function must be consisting of 3 parameters, which I've mentioned here, 1, 2, 3. So you should try to model the HV substation. When I say HV substation, see, as I've already mentioned, we are going for this is not with respect to the operational one or short term. This is basically with respect to a long-term planning, because planning, obviously, when I say planning, it is nothing but a long-term one. So the cost is involved in every case. So that's why I've included cost of the HV substation When I say HV substation, inside that obviously you will have a transformer. So it is nothing but you have to invest include the cost of a HV transformer and its losses. And then when you take the medium voltage transformer, because when I say a substation, it will have HV side and the LV side, and in the LV side you will have a small transformers. In the LV side you will have some transformers, so that should also be taken into account. And in order to have the feeder, because these are the important parameters, you should have the substation in the right place. You should have the substation in the right place. You should have the transformers, obviously, and that should also be taken care. And the lines, like 11 kV or 33 kV lines, which is trying to travel from the substations to the load centers, whether the connectivity is ensured or not. So all those things must be taken into account. So here, if I talk checking the connectivity, you can refer to the concept of topology processing under the area of power system state estimation, because as I mentioned, it is an interdisciplinary study. Okay, wherever possible, I'll just try to coin or try to relate the term which is already known to all of us. So in order to check the connectivity, the best way is either you try to get the signals from the lines, or you can adopt the algorithms which is suitable for topology processing related to state estimation. And then finally, you should, after these are the three main variables I've taken for this case study, and I have to add all the cost involved in this. That becomes my objective function. Yes, and suitable constraints. The constraints may vary. For example, if you're going to replace the substation transformer, what is the effect of the lines? This may be a constraint. If you're going to replace the transformer, what is the loading capacity of the new transformer which is going to be installed? And whether that capacity is capable enough to face the lines. For example, if I have 1 MVA transformer, and if I have a lines which is already installed which can carry 1 MVA power, but let's say if you're trying to boost, since you're going to invest money, and since it is a planning activity, obviously you should try to think with respect to the regular aspect also. So let's say if you're going to go for 1 MVA instead of 1 MVA, going for 2 MVA, let's say. So obviously the lines must also be designed in the same manner. So these are some of the constraints which you can think of, and you can apply as the constraint for the objective function. And see, now comes the resilient modeling. Till these two slides are very common to us, but this is slightly very important, especially in the case of a resilient model. As I said, the system is facing the weather. For example, in this case study, I have taken the wind. Wind is going to hit the substations and the lines. So what generally people will do is, they'll try to create a grid model, grid in the sense not the power grid, this grid model, and each and every block with respect to the vulnerability, they'll try to map. Okay. For example, if we are going to take our system, as I mentioned, I was trying to find with respect to this point of view. So for example, this region, the number 97, let's say in this point, this is a geographical map. This is geographical map, which is converted into a grid map. Okay. Rather, you can just take the direct map also. If you have the GIS location, in that particular location, what is the wind speed? If you have the data and if you have the component, you can try to do vulnerability analysis, and based on the result, whether it is more vulnerable or less vulnerable, you can decide, and you should have this data prior before the strategies which you develop. Yes, fine. Now, the same thing I've mentioned, whatever this slide, I've just mentioned those things. So for each block, what is the maximum wind speed that is mapped? Okay, and the distribution infrastructure like poles and transformers. So this geographically should be mapped, and the vulnerability of or the probability of failure must be mapped with respect to the fragility curves, which I think I've explained in this slide, if you remember. Yeah, based on the component fragility curve, we should try to find what, let's say, if this is the wind speed which is occurring. So the probability of failure is 0.3. Let's say if this is the wind speed is occurring, let's say the probability of failure is 0.9. So relatively, you should try to give numbers for all the components which is there in the system. So this is what becomes very hectic, and you need to have a real-time analysis in order to perform these data. Yes. So in summary, I want to say that you need to perform vulnerability analysis of the distribution system and find the vulnerable equipments and increase the strength of it. And to do so, what is the cost which is involved? So you are going to optimize this. This is what it is all about. Okay. And coming to the aspect, till now I did not touch the major part of the renewable energy resources, but it's not so different from the discussions which we had till now. If you are going to enhance the resiliency via installing the renewable energy resources, you can have a system like this, the conventional lines, and you just have to install the renewable wherever necessary. For this, I've taken another case study, like renewable integrated into the system, which can be clustered optimally to form small microgrids, as I mentioned in this slide. I'm going to have small microgrids, and the renewables must be installed within the microgrids. So how many number of clusters I should go for? I can have a algorithm for that as well. The popular algorithm which people generally use is K-means. Otherwise, you can also use machine learning and SVM, space vector machine techniques also you can use, and you can try to cluster the given thing. And when I say cluster, the clusters are done basically with respect to some means. For example, let's say in this situation, I'm going to take the same grid. Maybe this part of the grid, since it is very nearby, I'm going to cluster this one, I'm going to cluster this one. This is basically done with respect to distance or electrical distance, I can say. Or other parameters also you can take. For example, you can take the load density of a particular district or a particular region, and then you can do clustering. So it depends on completely on what basis you're trying to cluster. And then we should try to ensure that for each cluster, it is better in this case, that in this case we have considered the distribution distance, the line, the electrical distance, I mean. So that is considered, and based on that the clustering is done for the case study which I am trying to discuss now. So we should also try to ensure that some renewables must be there in order to satisfy at least the critical loads. When I say critical loads, I have already mentioned that the hospitals or the community halls, maybe if you can add whatever is essential for you, that should come under the critical loads. Yes. And then, since you are involving the renewables into the picture, obviously it is very essential for us to include the uncertainty involved in these renewables. Not only renewables, we should also try to involve the uncertainties which is involved in the loads as well as renewables, I should say. So that is one aspect. And if you are trying to lay extra lines or feeders in order to link these clusters, for example, in one cluster maybe it is like I think in power system operation and control, I think we would have studied area 1 and area 2. Between that there is a tie line. So we can have a tie line between the microgrids in order to even strengthen our grid, even strengthen our distribution grid when the disaster is going to occur. But obviously a cost involved for it, and it has to be taken care in the objective function which is presented here. Yes. Now, once this is done, how do I formulate? I'm just going to give you a generic idea for this case study. What are all the energy sources? If it is already available, then it's fine. If it is not available, you have to install it. So that's why I've added the cost of energy resources. When I say energy resources, obviously it means that RERs. Okay. And if it is already there, then you have to take, you can subtract it depending on your convenience. You can try to model this objective function. And the extra feeders which you are going to connect, if it is not there. If it is already there, then you can try to include the maintenance cost for it, for example, if you want. And then the input data, as I mentioned, the geographical data is very, very essential because you have to develop a diagram like this, right? The geographical data is very, very essential. The technical data when I say the power, the load, what is the type of feeder I have, bus feeder, 11 kV, 33 kV, all those technical data are essential. And then load forecasting, obviously it is important for you in order to serve the load which you are anticipated. And if you have a solar PV in the system or if you have a wind in the system, then you need the irradiance and the wind speed data as well. So similar to the grid which I have shown in this picture for this case study, there is another grid model. It represents the load density. So based on this, we have clustered, and based on that also you can try to just make a note of it. And the point to be noticed here is, as I mentioned, you can go for clustering algorithm, load points. You can constrain that with the voltage magnitude, all the voltage magnitudes. If it is same, then you can go for clustering. So it is completely depending on the power system planner on how to plan this. The main aspect is uncertainty modeling. So how do I model the uncertainties which is based on renewables and loads? So basically, generally in all the literature, or even we have also done in the same manner, that there should be some pattern which is followed, there should be some distribution. So we have taken for solar beta probability distribution function. For wind, most of the people will take Weibull distribution function because it has both, we have the control over both scaling and shaping factor in order to fix for any particular site for wind. So that is there. And for load, we will try to take the normal distribution function. Now, all these things are done, as I mentioned, in order to reduce this and in order to reduce this curve and in order to reach the point which is already there. So, So during the event, I've already explained this. So during the event, this is the case, and immediate after the event, this is the case. And after the event, what are all the plans you have so that you can restore the grid? So this is what I have mentioned in the slide, slightly in a different manner. Yeah, as I mentioned, resiliency index, this is very, very essential. For how much time, I think this is not so clear, I guess. So you can refer this. For how much time I can able to serve this power. That's what the resiliency index will tell. Simply to say, what is the time for which you are serving the load if the disaster is occurring, or I should say during the disaster, how much time you can able to supply the load. In other words, I can say a withstanding capability of the network during the event. And down means the network is down, obviously, and you need some recovery time in order to fix that. So this is a very common resiliency index which I have specified, but based on the complexity of the problem you have developed, so relatively the resiliency index might also be behind resiliency index is the same. So the time for which you are serving, especially during the emergency condition, with respect to the total time. For example, yes. So for example, if this is the timeline, if this is the timeline, here time and your system performance, let's say S. During this event, before event, the system is there, and because of disaster, it came down, and you have taken some time, recovery time, and then immediate afterly, how fast you come and develop the system to its original position again. So here, I just want to mention one more point, which I haven't included in the slide, that if you include REs and if you have all these setups, basically, if you try to improve the hardening, what will happen is, let's say this is the earlier curve, instead, it will try to reach some other state, like this. So you have improved the capacity of the system via hardening by this much. I hope I'm clear. So this much capacity is added. Either it can be through energy storage system, or it can be through your renewable energy, solar PV plant. It can be through anything, but you have improved the system. So this is what hardening is all about. So hardening comes with a cost, but obviously it will respond and it will not go make your system completely down. The system performance will still be there. Yes. And as I mentioned, again, I'm going to repeat it. In this case, the degree of fragility curve is taken, and the degree of fragility for a hurricane is obtained for the particular zone. And these are the fragility curves for network poles and the feeders. Poles in the sense, yeah, poles and feeders. So if the wind speed is, let's say, 120 meter per second, so this is the probability of failure you have. And if the wind speed is 120 meter per second, this is the probability of failure you have for feeders. Yes. So this is very essential for you to do. And then similarly, you can go for clustering. For the sample case, whatever I've taken, the clustering is performed. And based on the clustering, you can say that we should have each clusters. There are, I think, 14 clusters. Yes. So for each cluster, you may have the renewable energy resources in order to satisfy the load, which is specified. And then ultimately, in the end, the resiliency index must be improved. So how far you are trying to satisfy the load. So this should be your result. So till this, in this slide, the case study is done. So this slide, here we have written an article which is published in IEEE. We have proposed a general approach to enhance resiliency. I'll share this slide, this PPT. You can just click here, and if you want, you can just read the article. And in this, basically what we have done is this focuses on the energy storage system. What approach we should follow for energy storage system planning in order to improve the resiliency. So we have proposed a very generic approach which combines all the methods which is available, and our own ideology is also placed. And in this article, I've also taken the Chennai floods into account, and that's why I could speak much about that. If you want, you can read this article because it is related to, yeah. And then there is one more article which we have worked on with respect to the UPCL. So this is the grid which we have developed in the software Dixal and Power Factory, the Dehradun distribution grid. So we have placed the ESUs. I think you can see here, I have mentioned the locations of the ESUs which we got, and we have proposed this model to the UPCL, Uttarakhand Power Corporation Limited. So if we could able to install in the specified locations, we can able to form the microgrids like cluster 1, 2, 3, 4 amongst the Dehradun district, and then we can have the power supplied at least for the critical loads which is present in that particular cluster. So again, the link is specified here. So if you wish, you can read this article. Thank you. I think approximately 3 minutes left. If you have any queries, I'm open to queries. And I have references also. If you want, you can have a look. Yeah. Any queries? Hello, am I audible?
Sir, you're audible, sir. Participants, any queries from your side, please?
At least ask the queries, because I just completed the PPT before 2 minutes of my presentation, so I'm eagerly waiting for queries. And I think I can share some practical aspects since I was involved in the improvement of resiliency with respect to Dehradun distribution grid. Maybe I can share some practical aspects as well. And moreover, I'm a distribution engineer trainer, so if possible, I can give my aspects. Yeah, please. For your feedback. Thank you, Mr. Vinod Kumar. Yeah, there is the answer to Sonu Kumar. The resilient modeling is very helpful, especially where the places are prone to natural disasters. And if it is not done, then you can just imagine, just go and try to find out the report which is generated related to Chennai floods. You can see improper planning can lead to disaster. So basically, in terms of those reports you can find basically in terms of the property loss, but this power system resiliency is nothing but how do I improve the system, keeping my equipments safe as well as improving the energy served for the particular period of time. Especially it is important. For example, you can say, especially in India, we always think that we should have your own backup. But why should I have backup if I have a connection which is obtained from the electricity board? It is the responsibility of the people to serve power, to give power for you. And if this electricity becomes the fundamental right, then since in America, you see, electricity is the fundamental right. Internet is also a fundamental right. So I don't think so about electricity, but internet is the fundamental right for them. And if this is the condition, I think it is your right to ask the power, and it is their responsibility, the distribution company's responsibility to give the power for you. Yes, any other questions? And to be frank, in Dehradun district, especially this is the capital of Uttarakhand, the power cuts are not longer. Maybe I can say 3 minutes or 5 minutes or not more than half an hour. Definitely not. I can say this is mainly because of the ABC conductors which is installed throughout the distribution grid, at least in the Dehradun district region. So that I can say it can really impact. Yeah, how to change on power system components? So can you be clear on the question, Mr. Sonu Kumar? Yes. Any other questions? Can you see the slides for references?
Sir, influence of weather and climate. A question from Sonu Kumar.
Oh, I'm sorry. I was answering the, but I could not. I forgot to switch on the mic. I'm sorry. I was answering that only. Yeah.
Yeah.
See,
Okay.
I repeat. I already told this point with respect to the vulnerability analysis. See, vulnerability analysis. The main core importance of that is how the weather is going to affect your system. How vulnerable your system is towards the weather. Let's say flood, or it may be your earthquakes, or it may be anything. So there are models, standard models which is developed. I think I should type here FEMA, FEMA model. You just type in Google FEMA, Federal Agency. From there you can have HANS models, HANZUS, and based on that you can have. But the point is, there all models are not there. Some models are to be developed for country specific, because I can definitely say the standard which is followed by American people and the standard which we follow in India, it's completely different, because they follow IEEE and we follow IEC. Maybe the limits are more or less same, but the point to be noted here is the conditions are going to be different. The soil conditions are going to be different. For example, if you are going to have an earthquake, I'll just give you an example. If you are going to have an earthquake, the point is you don't have any equation for earthquake for a particular location. So institutes like Wadia Institute of Technology, I think they have already done. It is in Uttarakhand. It's a government university where basically it deals with the geology and it studies the Himalayan region. So since we had an interaction with them, they have developed an earthquake model to develop the PGA curves. So because vulnerability analysis, the input of the vulnerability analysis is your PGA in this case. In the case study which I have explained, since it will be more relevant for you, I have explained in the case of wind. So wind is the input. Similarly, your PGA will be input, peak ground acceleration. So where do you get the PGA? Because you cannot say an American soil is similar to the soil which is present in maybe UT. So you should try to have those studies, otherwise it is going to be difficult. Yes. Any other queries? So as I mentioned, the power system resilience is not completely related to power system. It is an interdisciplinary study where you have to link all the people and then you have to work it on. Cyber physical, the methods which you can use for cyber and physical. Cyber and physical combined. When I say physical, the vulnerability analysis is there. When I say cyber, you should have required firewalls, which is to be installed in each and every device, and you should make sure that it is not being hacked. That is the only thing we can do. Any other questions?
Any other queries from participant side? Okay, Chintamani ma'am. Chintamani ma'am, you are there?
Yeah, short-term resiliency is nothing but, let's say, as I mentioned, you have to plan for the crew. Let's say tomorrow or maybe after 2 days, the flood is going to come. This will be coming from the weather report, IMD.
Okay, ma'am.
Mr. Ramanan will be saying you, maybe in the past, Ramanan will be saying that tomorrow rainfall occurs. It never occurs. That is another case, just for joking. So rainfall occurs or some cyclone is going to happen. You have the prior information related to that. So depending on that, what are all the actions you try to take in order to decrease the damage? The best thing is, for example, the crews which you try to deploy there in the locations where the flood happens. Let's say the area is in Velachery. Okay, and you have a substation in the low lying area. You should have the crew installed there to pump the water out of the substation. So this can be done in the short notice of time. So you can classify like this: whatever the stuffs you can do related to a short notice, that can be classified under short-term resilience. Basically, time matters. Yeah. Any other questions?
Nagalakshmi ma'am?
Yes, ma'am.
I'm mentioning my mail ID.
Yeah, okay, sir.
If you have any queries, the participants,
Yes.
you can ask. I can mail to them, and I can share some of my data to them if they require.
Yes, sir. Definitely. Thank you.
Yeah, this is my mail ID.
Yes, sir.
I'll share the PPT also. I'll mail to Chintamani ma'am, and I hope she can share to all.
I'll be sharing, sir. I'll be sharing to all the participants.
Yeah, thank you.
Okay, sir.
Any other
Thank you,
queries?
ma'am.
Okay, shall I take the lead?
Yeah, sir. Just a moment, sir.
Yeah.
Yes.
Nandini, ma'am?
Yes, ma'am.
Yeah, ma'am.
So good evening all. First, I want to thank our respected speaker, Mr. Balaji Venkateswaran, for spending your valuable time and sharing your knowledge with us, sir. It was really a wonderful and informative session, sir. And I also want to thank our management, principal, vice principals, and our head of the department for their excellent support and valuable suggestions given by them. And I also want to thank our participant for your patience and making the faculty development program on the topic recent trends on development, recent trends on renewable energy and electrical vehicle technology. So it is a great success have been done. So thank you all.
Thank you all for patiently listening to me. There are a few doctorates here, and I hope I'll be a doctorate maybe at the end of the year. Thank you all. This is my area of research, so that's why I could able to throw all of my research for the past few years. So thank you all for patiently listening to me.
Thank you,
Thank
sir.
you.
Thank you, sir. Thank you, sir. Balaji sir, thank you, sir. Very informative section, sir. Thank you so much.
Thank you for all your genuine feedbacks. Thank you. I'm taking it that way. Thank you.
Thank you so much.
Okay, sir. Thank you, sir. Thank you.
Participants, the feedback link is shared in the chat box.